Kirby Air Ride is a racing action game made for the Nintendo GameCube. Kirby rides a star and can glide in the air when driving off a ledge. There's a few different game modes, but the main one people care about is City Trial, where 4 players drive around a city collecting power-ups that raise their stats, ending in a random battle that tests either combat, flight distance, speed, and so on. So if we want to create a game inspired by it, let's start by designing a character and vehicle. And here he is. I gave him a mischievous look with an impish grin and horns. I gave him a coat to ensure he doesn't get too cold. His eyes and mouth are 2D textures placed on top of a few invisible faces. So now that we have a character, let's give him some basic animations. The primary actions are sitting on the vehicle idly, turning, and flying. Let's start by giving him a skeleton that can control his limbs and head. When idle, he'll sit down holding the front of the vehicle. When turning, we want him to look in the direction he's facing with his hand turning with him. Now for the flying animation, we'll have his feet waving in the air behind him, as if he's struggling to keep his grip on the vehicle. And of course, we'll need a transition from sitting to flying. And now we have a good starting place for a player character. And of course, we need to model a vehicle for him to ride. That's not what I had in mind, but maybe we'll change it later. It's a bit silly, but it would be funny to have it spin when charging up a boost. Now let's bring it into Godot. Now we have a character and vehicle together, but I know how we can make it a bit more stylistic. There's another Kirby game I'd like to draw inspiration from, Kirby Battle Royale. The game kinda sucks, but the box art has some cool stuff going on. There's this dotted texture overlaid on the characters and objects, laid out like a gradient going from large dots to small dots. The effect doesn't appear in the game, but I'd like to add it to mine. Luckily, I found someone who made a shader with this effect in Unity, but since I'm using Godot, I'll have to make some alterations. Not like that. There we go. I changed the dots in favor of hexagons, since hexagons are the best shape. Notice how when the character moves, the pattern isn't fixed to the model, similar to the cartoon Chowder. But when zooming out, the pattern stays the same size, making it look a little strange and inconsistent when the character has these giant shapes instead of small ones. So we'll scale the texture to become smaller as the character distances itself. Now we have to code in some gameplay. And just like that, we have some movement. The character will automatically accelerate forward and turn slowly normally. The player can brake, slowing their movement down and increasing their turning speed. Braking charges up a boost, and when charged long enough, the player gets a boost of speed. But since we want braking to function as a drift, we have to think about how drifting works. In real life, a car basically always moves in the direction it is facing. But since drifting is when the wheels are sliding across the ground, it'll slide in the direction it was previously moving in, gradually lose that momentum, and begin to move in the direction it is facing again. So to implement this, we create a variable containing the rotation of the player when the brake first begins, and move the player with a force consisting of both their initial rotation and their current rotation. But doing this creates an issue where turning 180 degrees means the initial rotation and the current rotation are canceling each other out, causing strange behavior. To fix this, we'll update that initial rotation periodically to allow more dynamic momentum changes. We'll also make the player decelerate quickly when moving straight, and slowly if they are turning a lot. This way, players can extend their drifts to get around obstacles. To top it off, we'll make it so if the player is completely stopped, they can hold up or down to slowly drive forward or backward. So now we have to add some flying physics. If the player manages to leave the ground by driving over a ramp, they should enter an airborne state, being able to throttle up and down. But first, we have to make ramps work. Let's make a ray cast down, getting the ground's rotation, and having the player rotate to match it. Now we have a way to ride on angled ground without looking odd. Okay, so let's disable gravity when leaving the ground and allow throttling. We'll set a limit of 60-degree rotations when throttling, so the player doesn't do this. And 45 degrees for horizontal rotations, so he doesn't do this. And when the player doesn't input rotations, he'll slowly return back to his default rotation. In the original game, as you stay airborne for longer, your flying power decreases, effectively increasing gravity over time. So we'll count the duration of airtime in seconds, and increase the downward pull the longer he's airborne. And holding the brake button will send the player straight down. Now let's return to the ground movement. In the original game, when you hit a wall at an angle, the player will automatically rotate to align with the wall. That way, the game becomes both easier to play, and it improves on the pacing to reduce slowdowns. So when the player hits a wall, we'll detect the angle of the wall in relation to the player's rotation. If the player hits the wall too straight on, or if they're moving too slowly, we won't align the player. But if the threshold is met, we'll find the correct angle and apply the rotation. Now we'll add a spin attack. Flicking the control stick from side to side quickly causes Kirby to enter a spinning state, doing damage to opponents. Since we don't have any enemies in the game currently, we'll focus on the spin's secondary function. Hitting a wall while spinning causes the player to bounce off of walls, rather than aligning him. So how do you detect the stick flicking motion? My solution was to store an array of the stick's position. Every frame, the array elements get shifted to the right and the current position gets added to the beginning. So now we have the recent history of the stick's movement being stored, but we have to analyze it in a careful manner. First, we'll make sure the stick's position is currently to the side, which would have potential to be the ending motion of a stick flick. So if that condition is met, we then had to look at the duration of time since the stick was in the last opposite direction. If the duration is too high, that means the player didn't actually flick the stick quickly and would cause unintentional spins. Next, we must check to see that the stick's opposite side wasn't held for too long. If we don't check, then that means the player could be turning to the right for an extended period of time, and turning sharply to the left would cause a spin. We don't want that. So we'll make sure the opposite direction was only held for a short amount of time. Now that we can detect a stick flick, let's make it do something. I didn't make a spinning animation for the character yet, so for now we'll rotate the player's model for a couple seconds instead. And we'll return to the wall alignment code and make it so if the player is spinning, it'll instead bounce their momentum against the hit wall. And there you have it. We've constructed a solid foundation for the game, giving the player fun movement options and an artistic direction. I have plans to add different methods of combat eventually, and to make a map. If you have any suggestions, please let me know. And if you have a name for this guy, put it in the comments. If you'd like to see how this game progresses, please leave a like and subscribe. Thank you so much for watching, and goodbye.